The 2023 edition of NFPA 70E proposes a new requirement for the calculation and labeling of arc fault current levels on each piece of electrical equipment. The purpose of this requirement is to provide personnel with more accurate information about the potential hazards associated with electrical equipment, including the risk of arc flash. Equipment rated 240 volts or less shall be labeled to indicate the calculated arc fault current for the equipment. The label shall be prominently displayed on the equipment, visible to qualified personnel, and applied in accordance with the manufacturer's instructions. The label shall indicate the following information: calculated arc fault current, protective device type and setting, and arc flash boundary distance. Equipment that is not capable of producing an arc fault or that has been evaluated and determined to have a negligible arc fault hazard shall not require labeling. The NEC and NFPA 70E recognize that arc faults are a significant workplace hazard, and the calculation and labeling of arc fault current levels is an important step towards reducing arc flash risks. This requirement will provide personnel with the information they need to make informed decisions about the selection and installation of electrical equipment, as well as the safety precautions that need to be taken when working on or around electrical equipment. The proposed revisions to NFPA 70E are currently in the public review and comment period. The final version of the standard is expected to be published in early 2023. Arc flash is a dangerous electrical explosion that can occur when a fault happens in an electrical system. It releases tremendous amounts of energy in the form of heat, light, and pressure. The temperatures can reach as high as 35,000 degrees Fahrenheit, which is hotter than the surface of the sun. Arc flash can cause severe burns, blindness, hearing loss, and even death. It can also damage equipment and disrupt operations. Firstly, understanding the key changes in NFPA 70E 2023 is important, focusing on equipment-specific arc fault current labeling, the location of the label, the format of the label, and any possible exemptions. Secondly, equipment rated 240 volts or less must have a label indicating the calculated arc fault current. This will assist in understanding the potential hazards of the equipment. Thirdly, the label must be prominently displayed so that qualified personnel can see it easily. It must be applied according to the manufacturer's instructions to ensure proper adhesion and readability. Fourthly, the label should include three key pieces of information: calculated arc fault current, the protective device type and setting, and the arc flash boundary distance. This provides a comprehensive picture of the potential hazards. Fifthly, there are exemptions for equipment that cannot produce an arc fault or equipment that has been evaluated and deemed to have a negligible arc fault hazard. This prevents unnecessary labeling. The calculation of arc fault current involves several factors. These factors are the available fault current from the utility, the impedance of the electrical system, and the characteristics of the protective devices. The available fault current from the utility is the maximum amount of current that the utility can deliver to the electrical system under fault conditions. The impedance of the electrical system is the opposition to the flow of current in the electrical system. The characteristics of the protective devices are the current and time settings at which the protective devices will trip and interrupt the flow of current. The arc flash boundary distance is the distance from the arc flash source at which the incident energy is equal to 1.2 calories per centimeter squared. This is the level of incident energy that is considered to be the threshold for a second-degree burn. The calculation of arc fault current and arc flash boundary distance is a complex process that requires specialized knowledge in software. There are many different software programs available that can be used to calculate arc fault current and arc flash boundary distance. Some of the most popular software programs include EasyPower, SKM Power Tools, and ETAP. These software programs use sophisticated algorithms to calculate the arc fault current and arc flash boundary distance based on the electrical system parameters. The labeling of electrical equipment with arc fault current and arc flash boundary distance information is an important step in protecting personnel from arc flash hazards. By providing personnel with this information, they can make informed decisions about the selection and installation of electrical equipment, as well as the safety precautions that need to be taken when working on or around electrical equipment. The NEC and NFPA 70E recognize that arc faults are a significant workplace hazard, and the calculation and labeling of arc fault current levels is an important step towards reducing arc flash risks. The arc flash boundary is the calculated safe distance from exposed energized electrical conductors or circuit parts. If an arc flash occurs, this boundary is where a worker would be exposed to a curable second-degree burn, which is 1.2 calories per centimeter squared. The incident energy is the amount of thermal energy impressed on a surface, a worker, at a specific distance from the source during an electrical arc event. It is typically expressed in calories per centimeter squared. Understanding these concepts is crucial for electrical safety. The proper use of personal protective equipment, or PPE, is extremely important as well when working within the arc flash boundary. PPE includes flame-resistant clothing, safety glasses, hearing protection, and insulated gloves. The specific PPE requirements will depend on the incident energy level. Always de-energize equipment before working on it whenever possible. This is the most effective way to prevent arc flash incidents. If de-energizing is not possible, use safe work practices, such as maintaining a safe distance from energized parts and using insulated tools. Regular inspections and maintenance of electrical equipment can help to identify and correct potential hazards before they lead to arc flash incidents. Proper training is essential for electrical workers. They need to be trained on the hazards of arc flash, how to identify potential hazards, and how to use safe work practices. The 2023 NFPA 70E revisions related to arc fault labeling are a significant step toward improving electrical safety in the workplace. By understanding the new requirements and implementing appropriate safety measures, one can reduce the risk of arc flash incidents and protect personnel from injury or death. It's important to consult the official NFPA 70E document and any local regulations for complete and accurate information. Stay informed about the final version of the standard once it is published in early 2023. Arc flash hazards are often underestimated, but they are a real and significant threat to electrical workers. The energy released in an arc flash can cause severe burns, blindness, hearing loss, and even death. Therefore, it is essential to take arc flash hazards seriously and implement appropriate safety measures to protect personnel. One of the most important steps in protecting personnel from arc flash hazards is to conduct an arc flash risk assessment. An arc flash risk assessment is a systematic process of identifying potential arc flash hazards, evaluating the likelihood and severity of potential arc flash events, and developing appropriate control measures to reduce the risk of arc flash injury. The arc flash risk assessment should be conducted by a qualified person who has the knowledge and experience to identify potential arc flash hazards and evaluate the likelihood and severity of potential arc flash events. The arc flash risk assessment should be documented in writing and should be reviewed and updated regularly. The arc flash risk assessment should include the following information: identification of potential arc flash hazards, evaluation of the likelihood and severity of potential arc flash events, development of appropriate control measures to reduce the risk of arc flash injury, documentation of the arc flash risk assessment, and review and update of the arc flash risk assessment. Once the arc flash risk assessment has been completed, the next step is to develop and implement appropriate control measures to reduce the risk of arc flash injury. Control measures can include a variety of engineering controls, administrative controls, and personal protective equipment. Engineering controls are physical changes to the electrical system or equipment that reduce the risk of arc flash injury. Engineering controls can include arc-resistant switchgear, current-limiting fuses, and remote racking devices. Administrative controls are changes to work practices or procedures that reduce the risk of arc flash injury. Administrative controls can include lockout-tagout procedures, safe work permits, and arc flash training. Personal protective equipment, or PPE, is equipment that is worn by personnel to protect them from arc flash hazards. PPE can include flame-resistant clothing, safety glasses, hearing protection, and insulated gloves. The selection of appropriate PPE should be based on the incident energy level at the work location. The incident energy level is the amount of thermal energy that a worker would be exposed to in the event of an arc flash. The incident energy level is typically expressed in calories per centimeter squared. There are a number of different methods that can be used to calculate the incident energy level. One common method is to use an arc flash calculator. Arc flash calculators are software programs that use the electrical system parameters to calculate the incident energy level. It is important to use a qualified person to calculate the incident energy level. The qualified person should have the knowledge and experience to select the appropriate calculation method and input the correct electrical system parameters. Once the incident energy level has been calculated, the appropriate PPE can be selected. The PPE should be selected to provide adequate protection from the calculated incident energy level. It is important to inspect the PPE before each use to ensure that it is in good condition. Damaged or worn PPE should be replaced immediately. Personnel should be trained on the proper use of PPE. The training should include how to don and doff the PPE, how to inspect the PPE, and how to care for the PPE. In addition to engineering controls, administrative controls, and PPE, there are a number of other safety measures that can be taken to reduce the risk of arc flash injury. These safety measures include maintaining a safe distance from energized equipment, using insulated tools, and avoiding contact with energized parts. Maintaining a safe distance from energized equipment is one of the most effective ways to reduce the risk of arc flash injury. The safe distance is the distance from the energized equipment at which the incident energy level is below the threshold for a second-degree burn. The safe distance will vary depending on the voltage of the equipment and the available fault current. Using insulated tools is another important safety measure. Insulated tools are designed to protect workers from electrical shock. Insulated tools should be used when working on or near energized equipment. Avoiding contact with energized parts is another important safety measure. Energized parts should be treated as if they are always energized. Contact with energized parts can result in electrical shock or arc flash injury. The new arc fault current labeling requirements in the 2023 NFPA 70E are an important step in protecting personnel from arc flash hazards. By understanding the new requirements and implementing appropriate safety measures, one can reduce the risk of arc flash incidents and protect personnel from injury or death. Always consult the latest version of NFPA 70E and any applicable local regulations for the most up-to-date information on electrical safety requirements. It is also beneficial to participate in regular safety training and continuing education to stay informed about best practices in electrical safety. The application of arc flash labels based on calculated incident energy is essential for worker safety. These labels provide critical information about the potential hazards and required PPE levels, allowing personnel to make informed decisions and take necessary precautions before working on or near energized equipment. Arc flash studies are detailed analyses of electrical systems to determine potential arc flash hazards. These studies involve calculating fault currents, determining protective device clearing times, and estimating incident energy levels at various locations throughout the system. The results of the arc flash study are used to create arc flash labels and to develop safe work practices. Coordination studies are engineering analyses performed to ensure that protective devices such as circuit breakers and fuses are properly coordinated to minimize the extent and duration of electrical faults. Properly coordinated systems help to reduce the likelihood of arc flash events and to limit the amount of energy released during an arc flash. The installation and maintenance of electrical equipment should be performed in accordance with applicable codes and standards such as the NEC and NFPA 70E. Proper installation and maintenance practices help to prevent electrical faults and to ensure that protective devices function correctly. Regular inspections of electrical equipment should be conducted to identify potential hazards such as loose connections, damaged insulation, and overloaded circuits. Addressing these hazards promptly can help to prevent electrical faults and arc flash events. Lockout-tagout procedures are used to de-energize electrical equipment and to prevent accidental energization while work is being performed. These procedures involve disconnecting the equipment from its power source, locking out the disconnecting means, and tagging the equipment to indicate that it is out of service. Safe work permits are written authorizations that are required before certain types of work are performed on or near energized electrical equipment. These permits specify the hazards that are present, the precautions that must be taken, and the PPE that is required. Before commencing work on electrical systems, a thorough job briefing should be conducted to discuss the hazards, the work procedures, and the safety precautions that will be followed. All personnel involved in the work should participate in the job briefing and should understand their roles and responsibilities. Electrical safety training should be provided to all personnel who work on or near electrical equipment. This training should cover topics such as arc flash hazards, safe work practices, PPE requirements, and emergency procedures. Qualified electrical workers are personnel who have the skills and knowledge to safely work on electrical equipment. Qualified workers should be able to identify electrical hazards, understand safe work practices, and use PPE properly. Always ensure that all electrical work is performed by qualified personnel who have received appropriate training and who are familiar with applicable codes and standards. Emergency response plans should be developed and implemented to address potential electrical incidents, such as arc flash events. These plans should include procedures for rescuing injured workers, providing first aid, and contacting emergency services. Regularly review and update electrical safety programs to ensure that they are effective and that they comply with applicable codes and standards. Solicit feedback from workers and incorporate their suggestions into the program. Create a strong safety culture within the organization that emphasizes the importance of electrical safety and that encourages workers to report hazards and to follow safe work practices. Electrical safety is a shared responsibility. Management, supervisors, and workers all have a role to play in creating a safe work environment. The goal is to minimize electrical hazards and protect personnel from injury or death.